joining us this afternoon. We're with the Astronomical League, and we are here to help promote and disseminate amateur astronomy to our membership and the public. Today, in celebration of our 75th anniversary of the Astronomical League, which actually was on November 15th, 1946, so we're not quite to 75 years. But we have a young person with us today, Makaila Jennings. She's going to be talking a little bit about exoplanets and about her interest in science and so on. I think this is a great opportunity for people like us to see how the hobby is advancing and how the science is advancing, and looking at people coming up through the ranks, such as Michaela, who is the future. People like her, we're really looking at and nodding our heads in approval. So with that, unless anybody has something to say, I'll turn things over to Michaela. Excuse me, one more thing. On our call today, we also have Astronomical League President Carol Orge. I don't know if he's on your screen, but he's on my screen. Hello, Carol. And Peggy Walker, by the way, who's on the 75th anniversary committee. And she's the one who did a lot of the legwork to arrange a lot of these talks that we'll be featuring today and the coming weeks and months ahead. So with that, Michaela, would you like to take over right now?
Yes.
Okay, could you tell us a little bit about yourself first?
My name is Michaela, and I'm really interested in astronomy and exoplanets. I'm in ninth grade and I'm homeschooled.
And you belong to the Von Braun Astronomical Society, right? In
Yes.
Alabama, yeah. So, okay. Yeah. So you got the program. So how did you get interested? Is John, you got your program ready to go? Are we ready for that?
Okay, Michaela, are you ready to screen share?
Yes.
Okay.
Oops.
Wow. Nice.
My name is Michaela, and my project is using the double dip transit photometry method to identify habitable exoplanets. The purpose of this experiment is to see if there was a super Earth and a hot Jupiter orbiting a star, would there be a double dip using the transient photometry method of detection. A super Earth is an Earth-like planet with the mass of Neptune, and a hot Jupiter is a Jupiter-sized planet that is close to its star. A hot Jupiter is easy to detect with transient photometry, but a super Earth is pretty hard to detect with transient photometry. A super Earth has a high chance of having life on it if it's in the habitable zone, but a hot Jupiter does not have a high chance of having life on it. So I wanted to see if a hot Jupiter and a super Earth were orbiting a star, would there be a double dip so you could detect the super Earth?
Pretty
My
cool.
rationale is one of the most important questions in astronomy is, are we alone in the universe? Since super Earths have a high chance of having life on them, astronomers should look to see if there are life on super Earths. But since super Earths are so hard to detect using transient photometry and hot Jupiters are super easy, I wanted to see if there would be a double dip if you were looking at a star and a hot Jupiter and super Earth were orbiting the same star. There are several methods of detecting exoplanets. The main three ways are transient photometry, radio velocity, and gravitational microlensing. Transient photometry is when astronomers look at a star and they see if there's a dip in the light coming from the star. And if there continues to be a dip in the light coming from the star, astronomers look for an exoplanet as the cause. Radio velocity is when astronomers use radio waves to detect exoplanets. And gravitational microlensing is when astronomers see if a star is being pulled by the gravity of an exoplanet. Two additional ways of detecting exoplanets are direct imaging and astrometry. My research questions were: will a super Earth following the orbit of a hot Jupiter cast a double shadow or a double dip? And how does the color of the star impact the ability to spot the double dip
Wow.
from the super Earth?
Okay.
My hypothesis was there will be a double dip using the transit photometry method that indicates that there is a super Earth and hot Jupiter orbiting star. And the color of the star will affect how well you can see the double dip.
Oh, wow. Okay.
So the first thing I did was make a model to simulate space. So I got a 4-foot box and I painted the inside black. I got a light meter that could change color, and I got a LED light bulb that could change color and brightness, and I put it on one end of the box. Above it, I had a motor with a string attached to it with a foam ball on the end to simulate the hot Jupiter. I placed that 5 inches away from the light bulb that simulated the star. I also had a pulley system with a small bead on the end to simulate the hot Jupiter. To simulate the super Earth, and that was 10 inches away. I had an Arduino light meter so I could detect dips in the light.
Wow.
And what I did after I recorded the data with the Arduino light meter was I put in an Excel spreadsheet for analysis.
Mm.
The first thing I did was I measured the luminosity of each colors of the stars, which are white, blue, yellow, orange, and red, from 5 inches away, 10 inches away, and 26 inches away, which were the distances of the hot Jupiter, the super Earth, and the light meter from the star.
Mm.
The results I got when I ran my tests were the yellow star, you can see the double dip every time. The smaller dips came from the super Earth, and the longer dips came from the hot Jupiter. For the
Okay.
blue star, you could not see any dips from the super Earth.
Huh.
For the yellow and orange stars, and also the red star, you could see a double dip the super Earth, but the orange and red stars, the double dip did not come as frequently as it did for the white and yellow stars. For the yellow and white stars, you could see the double dip every time. The yellow and white stars were the brightest stars, and they were the most effective at identifying the double dip.
Hmm.
For the red and orange stars, you could see the double dip less frequently than you could see for the yellow or white stars. And the red and orange stars, they were dimmer than the yellow and white stars. For the blue star, you could not see the double dip at all, even though it was a similar luminosity to the orange star. It was easiest to see the double dip when the star was brighter. And it was easiest to see the double dip when the lux of the star was above 30. When the brightness of the star was just below 25 lux, the color of the star determined how well you could see the double dip. My hypothesis was proven correct. There can be a double dip from a star if a hot Jupiter and a super Earth were orbiting a star. The color and brightness of the star affects the ability to see the double dip. The double dip was not detectable for the blue star, even though it's around the same luminosity as the orange star, which shows that not only the brightness of the star, but the color of the star affects how well you can see the double dip. The yellow and white stars were the easiest to detect the double dip, and this shows that if astronomers were looking for super Earths using this double dip method, they should look for high luminosity yellow and white stars if they were trying to spot a super Earth, if super Earth Jupiter were orbiting the same star. Um, this is important because if astronomers wanted to find super Earths because they have a high chance of having life on them, it would be easiest for them to look at these high luminosity yellow and white stars so that they could detect super Earths and see if there were life on them. Because it would be pretty hard if you were trying to spot a super Earth with the blue star, which you could not detect the double dip at all. But if you were looking at the high luminosity yellow and white stars, it was much easier to spot the double dip. So it would be easier to spot the super Earth, which has the possibility of having life on it. Does anyone have any questions?
Excuse me. I do, although it's not really a question. I want to comment that what you have done is something that I'm sure the ancient Ionian culture of Greece would approve. In their science, study of science, they would build elaborate models to help prove if something's correct or incorrect, whatever. And I think it's very admirable that you have taken the time and the effort to put together uh, a model. It's a model of showing how to do this. So you have your hot star, your cool star, your blue and yellow, and all that, and you have your Earth, different sizes and distances and light meters and such. So you're actually taking measurements to help prove or disprove your hypothesis. And that's pretty much what science is all about. You know, doing a lot of observations, um, trying to establish things, setting up things that you can measure, and that's what you've done. So I'll hand it to you for doing that. That's really cool.
It was a very clean project. You said it very obvious what you wanted to prove, and you did it very nicely. Went straight to the point, and well done.
Thank you.
Yeah, that is pure scientific method right there. You know what I mean? And are you observing any of these through a scope or anything for yourself?
Um, I haven't seen any of these double dips happen before, but I have looked at some transient photometry.
Okay, so are you have equipment that you're using?
Well, for my experiment, I made a model and I used an Arduino light meter, but I do have some telescopes.
Okay, well, the reason I'm asking is because I know a gentleman that it's from the Inside Observatory, and he's all about getting students involved with deeper sky using his scope that it's out in New Mexico, but you would be able to get time on it and do advanced study work on this. So I will send you his information. If you want to actually get in, you may be able to image exactly what you're looking at doing. But his whole goal is to get kids and get into the educational venue. So if you want to do advanced work on this and take it from the model that you have to actual observations and data collections, do you know what I mean? That he has a scope that is large enough in an observatory that you could run. You just have to get time on it, you know. And I don't know what he charges. I don't know if he charges or not. I don't know, but I know he does it for classrooms, and he knows certain students are using it to image and doing things like that. So if you want to take this to the next level, I will connect you to him so you can actually visually see what you just did with your model down here. Would that be something you'd be interested in doing?
Yes, thank you.
Okay, I will connect you with him. Okay. And what got you interested in doing exoplanets of all the things that you
Well,
have done?
I've always been interested in astronomy, and um, I wanted to see like if there were life on other planets outside of our solar system. So
Mhm.
I started looking into different kinds of exoplanets and different ways to detect exoplanets.
Because I know there's an app on my phone and I love going to it and I love seeing the multiple planetary systems off of a star. Have you found things that have more than one planet system? Have you been looking at those at all? Like the
Yes.
Jalees, some of the Jaleeses have like 6 or 7 planets attached to them. And do you follow like the Spitzer data? You know, when it went up into Singus and it did the huge survey of that area. Have you been looking at that data at all, or?
Um, I'm not sure.
Yeah, I would look at the Spitzer telescope and look up all the stuff that they discovered. It's not, I don't think it's in operation anymore, but the whole thing was about looking for exoplanets. And it took the Cygnus as the main constellation, but it scanned that whole sky. And it even gave us information on the X1 black hole in Cygnus. It's a Cygnus X1 black hole, but it did give a lot of data on exoplanets just in that region of the sky. So that might be something you can also add into, you know, doing more research. So you can get into observing and become more into the astronomy side of that, because you've already got the model. You already know how it kind of works in your head. But this would be a great way to just springboard you into observing. A great way to get started there.
I'll make sure to look at that.
Yeah, yeah. I'll see if I can find links to it and send you that too.
Michaela, have you presented this to the astronomy, your astronomy club? You're on the von Braun Astronomical Society. Have you presented it to them?
Yes.
Oh, good.
Yes.
And I
And
trust.
she's also National Science Teacher Award winner. Talk about how that happened.
Well, I've I've I did my projects. I've done multiple projects on finding exoplanets. So I decided to send my presentation to the National Association of um, Teachers, Science Teachers.
And then when did you win that award? What was that year was that?
It was last year.
Oh, sweet. Nice.
That's
Cool. That's awesome. So did your dad get you into astronomy, or how did you get into astronomy generally?
Well, my grandfather, he used to work for NASA during the Apollo.
Wow.
So I started learning some astronomy from him.
Nice.
It's a good place to start.
Yeah. It's in your gene pool. It's like in your gene pool, right? Oh my goodness. Okay. So what would you want to do educationally wise? Where do you see yourself going from here? And, you know, let's say you're done with high school. Where do you want to go?
Well, I've thought about becoming an astronomy professor.
Professor. Okay. And what would you major in? I mean, in terms of what facet, like exoplanet research, or you stay in that, or would you go into something else, or physics? Would you be like an astrophysics, or what?
Yeah, I thought about majoring in astrophysics.
Mm-hmm. So I think they also do stuff with radio astronomy and exoplanets. So radio astronomy might be another venue that you could go down. That would be interesting, I would think. Wow. Okay. I don't know. I just think I think it's phenomenal. I think it's great. You have a great scientific mind, and I just need to connect with people so you can advance what you need to do. And I did look up some, because I like them too. They said that there's certain stars that you can look at, and if you were to observe them over a 4-hour time frame, that you would see a star transit over them, but you just have to have large enough equipment to do that, and maybe a video camera or something like that. But I haven't done it yet, because Oklahoma gets a lot of weather and crazy stuff. So every time I plan to do something, it's like, oh, thunderstorms, dang, you know. So but I looked them up to actually see, I want to watch this happen. And I found one that would work in 4 hours, and I'd be up, but then the weather clouded me out and I never got a chance to go back and do it. So yeah. Anyway, so wow. Anybody else got any questions? I mean, I just think it's phenomenal. I just think you've got a great mind, and if we can help, the AL can help you in any way. And I don't know if you looked at some of the AL observing programs. Have you done that at all? Have you gone through if you go onto the website, there's all these programs that will teach you how to observe. So if you haven't, mastered certain things or learned how certain terminologies, like, is the sky transparent? What was the scene? get your skill sets, your physical observing skill sets up to a certain level, so that when you go into applying for colleges, you could go through and say, well, I've got, we have like 75 programs, right? You could go in and say, well, I've done like 60 programs for the Astronomical League. That would tie into a really good resume for you for college. So I would recommend that you start going through and looking at some of those programs and just become an observer, because you will learn terminology, how to do it, what the scene is. And as you go through, like Messier's and all these different things, how to observe the sun, there's lunar things, there's planetary. So they have them for everything you can imagine about astronomy. And I would do that, because then you could hone in even more, you know what I mean, on what you want to do, but you'll have the skills to actually do physical observing. And I think that would just be good for your resume when you get to graduate, you know what I mean? So that's where I would go. So have you ever gone to the website and seen those there at all? So if you just go to astroleague.org, and you'll get a page, and on the left side is a nice long menu, and you can go in there down toward, it's alphabetical, so you scroll all the way down and hit observing programs. Okay, and so from there you can click on, like, that gives you a overview of little probably like icons of what they are, and you can go through them and see, and maybe with your dad and help from the Braun Club, and I know Don Martin, who your president is, can get you started on going through these programs. Messier might be a good way to start on those. You can do binocular.
In fact, on the website, it breaks them down by difficulty. So,
Yeah.
And if you're not going to be able to be in dark skies or something like that, you could look at the urban program,
Right.
which you can see in the city. So there's lots of options there to start in gradually.
Yeah, and it just is all about getting your skills up. You know what I mean? So that you'll be marketable. You'll be going into college, and people will suck you up because they'll want you because you are an astronomer. See what I'm saying? You've got it up here. Now we got to get you physically observing and showing them that you've gone through all of these things, because it really is about discipline. And and when you start doing this, you're going to have to sit on a scope looking at these transit things and stuff like that. So you're going to show them your discipline by going through these programs. I think that you'll just automatically show that you've got it all together and you're already there. You know what I'm saying? So that's what I would recommend. And I will connect you to that other guy, but I really think you need to look at the AL programs and look at the difficulty level and have, people get started with you in your club. And you can always get back with any of us to help you with anything. If you got any questions or anything, we'll help guide you through any of that. You know what I'm saying? So I think that'd be a good place to go. A really good place to go.
There's another.
You're welcome. Yeah.
There's another set of programs that you ought to seriously take a look at. One thing the Astronomical League does is give away awards to young people, and there are a number of awards. But what you might be interested in is something called our National Young Astronomer Award. Look on the website for this; it'll give you all the details. But really, basically, what it is it's an award given to students who do a really good research project. And what do you get if this happens? Well, you get an expense-paid trip to our national convention. You get well, I shouldn't speak too far ahead, but you do get a nice telescope from Explorer Scientific. They're the sponsor of this award, a very generous sponsor, by the way. But most importantly, what you get is what Peggy's been saying. You get something really nice on your resume there.
Yeah.
Young Astronomer Award. That sounds pretty impressive, because it is. So go on the website and take a look at this and see if it's for you. And good luck.
Yeah. And the other thing is the American Astronomical Society has a list of all the colleges and universities in the United States that offer undergrad and PhD and master programs in anything astronomy or physics, astrophysics. So if you are looking at doing that, you need to look at what colleges are out there now. What do they need from you? Because you need to start building your resume to be able to submit to these colleges if that's where you want to go. So I would look at that as well. And I can send you a link to that. because it's like 14 pages, but it's all every state in the United States. And you might find something close to home, I don't know. But you want to be able to, if you find something you want, to be able to make your resume fit into what school you want to look at going to. You know what I mean? So that'd be another thing I'd look at. But yeah, you need to go to the award, go look at the observing programs. That would be the first place I would go. And then, yeah, and then continue doing what you're doing. So yeah, really, really good. You're really got a good foundation, I think. And you understand the scientific theory. My daughter actually was getting a PhD, had to do a lot of undergrad teaching and stuff. And even though it was biology, high school students were coming in, and of course, everything's about coming up with a hypothesis, coming up how you're going to test something, and then how do you come up and examine your results. High schoolers that graduated could not go down this road. And she finally said, look, you got to give me the AP students. I cannot teach high school kids how to write a hypothesis, how to speak English or write English. So he gave her all the AP students so she could actually get into the science and not have to do English with them. So so you already are ahead of the game. Most kids are not getting that, even in schools, is the scientific method and how to think. And you've already got that. I think that's really good, important. Yeah.
Okay, does anybody else have any questions? Carol, do you have any final comments here?
Just say, hang in there. I know sometimes as a young person in high school, you seem isolated because there's not a whole lot of astronomy being taught in high school, but just hang in there and blaze your own trail. Sounds like you got some good support systems with your club. And of course, we're really eager to help you in any way we can through the National Young Astronomer and any other thing you want to know about. So that's great.
Yeah, it's really good, really good.
Peggy, do you have any final comments here? Sounds like
Oh no,
so.
I just was enamored that when that she had done that already, and it was just I'm glad that you put that together, and thanks for you guys putting this on for her. But we just want to get more youth in the forefront of what's going on, because astronomy is usually predominantly older folks, amateur wise, mostly that. So it's exciting to watch up and comers come. So I really thank you guys for letting her have her thing, and then you guys can show this to you guys have your homeschool group or whatever. You can share this with them and everything like that. So this can go on your resume. It's a resume builder for you. So anyways, but you can get a hold of me. I will email you all this stuff. If you need me for anything, you know how to get a hold of me. So I'll be happy to help you. They're happy to help you. So yeah, anything you need.
Mr. Jennings, you've been pretty quiet there, but I bet you are pretty proud of your daughter.
Yeah.
Yes, definitely. She works really hard. She's our homeschool has been STEM based, and all our kids they've really gravitated towards STEM. And Michaela, she knew at her early age she liked science and astronomy, and she's into sci-fi, the Marvel superheroes. She's into Star Wars, and so she thinks well beyond our solar system here.
Right.
We're very proud of her.
Okay, Michaela, do you have any final words here?
Thank you for letting me present.
Oh, you're quite welcome.
Yeah.
Okay, with that, unless someone has something urgent to say here, we'll be signing off.
Okay.
We appreciate you taking your time and giving us this presentation. I'll try to have this posted on our Facebook page, probably, I always say within a few days, but you know me, it'll be a week, but we'll get up there.
Well, you're probably inundated with snow. I hope you're doing okay. But
yeah.
if he's freezing, yeah, I know.
Okay, everybody, thank you for attending, and thanks for watching.
Great.